Hey guys, in this video we're going to talk more about agents, but we're going to go deeper into a concept called MCP. So before MCP, when you're building agents and you want them to connect to tools, like let's say you want Claude to talk to Google Drive, you would have to write a custom integration that allows it to connect to Google Drive. And then you'd have to do this for other tools too. You would have to create custom integration from Claude to Google Docs, from Claude to Slack. You would have to keep on creating custom integrations. And then if you wanted to connect OpenAI to those same, if you wanted to connect ChatGPT to those same things, you would also need to create custom integrations too. And this gets confusing because you have to keep on making custom integrations, and you're probably going to have more than 10 tools. Like in the example we showed in the last video, we only had 2 tools, so it's pretty easy to create 2 custom integrations. But when you keep on making these custom integrations, it becomes redundant and it becomes really complex, and there's really no point in doing all that, which is why we have Model Context Protocol. Model Context Protocol, or MCP, allows us to connect 2 tools in one standard interface instead of creating a bunch of custom integrations. So a protocol that any model can use to connect to any tool. So Anthropic would build this protocol, and then the tool makers, the people who made the tools, would create MCP servers. And MCP servers say, here's how to read my data, and here's how you get to take actions. And any AI model that can speak this MCP language, that can understand the server, can plug into the tool instantly instead of you having to make your own custom integration. All the model has to do is understand how the tool works and how the MCP server works. So if Google Drive were to create some MCP server so that every AI model can use it, then it'll create only one MCP server. It doesn't have to create an MCP server for every single model out there. It only has to create one, and then any AI model can use it as long as you can know how to configure the MCP server and create your MCP client, which is the client side. And Anthropic released this concept of MCP in late 2024, and that's when it went viral. And a bunch of people started adapting it, and there are already hundreds of MCP servers for different tools. So there are a bunch of websites out there where you can find your own MCP servers. This one is called mcpservers.org. And there are a bunch of MCP servers that you can try out. Let's go back to the example from the last video where we talked about flights. Let's see if there's an MCP server for flight data. As you can see, there's a lot of flight databases. There's a flight planner where you can create detailed flight plans. There's Google Flights where you can interact with Google Flights data. Now let's go to calendar. We had a calendar tool too. Now there's a calendar MCP server too. Maybe you can connect with Google Calendar. So as you can see, there are so many MCP servers that people have built. And now you don't have to create your own custom integrations. All you can do is create an MCP client, which is your model, and connect it to this MCP server. So MCP allows agents to connect to tools. But what A2A, or agent-to-agent protocol, allows you to do is allow agents to connect to each other. It's like the Crew AI that we talked about before. It's an orchestration framework that allows agents to communicate with each other, where one can be a researcher, another one can be a writer, another one can be an editor, but A2A is what lets them coordinate. There's also ACP from the Linux Foundation, and it tries to do a similar thing. And a simple way to remember it, MCP is agent to tools, and A2A and ACP are agent to agent. Okay, so we can connect agents to tools, and we can connect agents to each other. But there's still another problem. You have a conversation with an agent one day, and you ask it to research something, and it does a great job. But then you come back the next day, and it has no idea who you are, and it has zero memory of what happened. Without memory, every conversation is going to start from scratch. And that's fine for if you're asking maybe one question, but most people use chatbots for more than one question. And it's kind of useless if you want to use an agent for multiple days to do multiple days of work. So there's 3 types of memory. There's short-term memory, and this is the context window that we talked about all the way in week 1. And this is what the model can see right now in the conversation. It only looks at the conversation. Claude, it has millions of tokens, but it's temporary. If you delete the chat, it's gone. But then there's long-term memory. It's kind of like the vector databases that we talked about with RAG. But instead of storing the company's documents, it stores the agent's past interactions. Instead of storing the back and forth of the user, it also stores the internal thinking, it also stores the tool calls that it made, and it's persistent across sessions. So if you start one conversation and then you start a new conversation, this long-term memory remembers some of the stuff in the last conversation you had. And that allows you to build preferences. So when you're talking to ChatGPT or Claude, it knows your past history because it has long-term memory of all your conversations, not just the conversation that you just started. It already knows your name. It already knows things you're interested in if you've talked about this in previous chats. Then there's episodic memory. Claude uses this a lot. It doesn't just store the facts, but it stores the narrative of what happened, kind of. It stores the mistakes that the model has made, and then decides that, oh, I made this mistake, so I shouldn't do this again. So if the user asked it to do something, and they tried approach A, but approach A failed, so then they do approach B, and approach B works, now they know that approach B works, and they won't try to do approach A again. And this is how agents can learn from their mistakes. Or if a user has some kind of preference in what they like if sometimes when you're making something with ChatGPT, it might give you a response and then you try to edit it and it only gives you the edited part back. Like when I'm coding, it gives me a file and I say, no, I don't like how you did this part. And then it only gives me the edited part back. But I want it to always give the full thing back. It's going to put that in its memory. If I specify always give me the full files, it'll put this in episodic memory. And then if I ask it to edit something, it'll always give me the full file. That's a good usage of episodic memory. But memory is probably the hardest part of building AI agents, because what part of the things do you want to save? But what do you want the models to forget? Because if you remember everything that happened, then your performance will start to degrade. So how do you retrieve the right memories at the right time too? I don't want to have that coding episodic memory example from before. I don't want that always on because I'm not always going to be coding. You see how hard it is to balance what you want to remember and what you don't? That's one of the challenges of building AI agents. AI agents are everywhere in the real world today. Of course, I won't go through all these examples individually, but it's important that you know that there are so many of them. And one of the biggest ones is Claude Code. And we talked about Claude Code a few videos ago in part 2. And Claude Code is a huge agent because it does tool calls to write things, to test things, to deploy code. Those are all tool calls that it does, and it's one of the biggest AI agents out there. But the honest part is that a lot of agents fail. They get stuck in loops or they hallucinate, and they sometimes do the wrong thing confidently. And every serious agent deployment needs guardrails, they need error handling, and it needs human oversight. So like when you're using Claude Code, if you put it in auto mode and it does something that you don't want it to do, the Anthropic company is still not responsible for that because they have an ask edits mode. And the purpose of the ask edits mode is to be safe. When you're coding, it does things safely and asks you for permission so you can understand what it's doing before it actually does it. If you put it in auto mode, the danger is that it does things on its own that it's not supposed to be doing or that you don't want it to do. So that's the full agent ecosystem. You can watch these 2 videos and understand the basics of agents and MCP. So I'll see you in the next video.